And I always like to start off my trainings with telling you that the install is the most important thing to installing a water heater, a commercial water heater, or even a residential water heater. And in the state of California, it's even more prudent because we have what they call ultra low NOx. Now, before it was low NOx, and then before that is what they called an open combustion chamber, which all three of them require certain things for you to do when you install a water heater in a closet or in a room or a mechanical room. The sheets that you have in front of you actually come from the booklet that comes with every water heater that nobody ever seems to pick up. And the reason why I start with this is because ultra low NOx means, anybody know what it means? Nobody?
Sealed combustion, is it?
Say that again?
Sealed combustion?
No.
You're not allowed.
No. It's part of it, but
Low emission.
low emissions. Exactly. The state of California says that we must burn everything that burns gas cleanly, including your fireplace in your house these days. They say that now you can't even sell your house that has an open fireplace. You now have to put an insert inside of it or something closing it off. Interesting, but it's part of low emissions. You gonna say something?
No, I'm just
Okay.
listening.
All right, so ultra low NOx means low emissions. If you were to take out your phone right now and Google ultra low NOx and how it works, three things are gonna come up, okay? It's gonna tell you that you must have combustion air, exhaust air, and proper gas flow. Those three things are so important to this unit. This is actually called a GNU, which GNU means, I forget what the G means, but ultra low NOx is what the U stands for. Right? They had a G series or something before, but the low NOx has to have those three things for it to actually operate properly. Now the question always comes up, well, it worked for a little while. Yeah, it might work for a little while if you have one of those three things wrong. But it will also cause problems that will shut this heater down, and you will have to go in and figure out what it is. But the mistake that is made, and particularly at the factory and at all levels, is that when it does shut down, everybody just wants to find a fix. Nobody wants to focus on what caused it, okay? And this is what this training is about today, is to teach you how to install it and then how to troubleshoot it if something goes wrong. But if you install it correctly, more than likely, these things come with a 3-year warranty. It's going to last the duration of that 3 years and then some, okay? Before I go any further, I'm going to tell you that there is also maintenance required with these heaters. Very important, and it's very small. All right. The page that I gave you, I don't know which page is on front of yours, but okay, yeah, we're on the same one. I took an arrow and I marked the most interesting part for me. It says 3 venting. It says, if you read through that, which I'll go through it if you'd like to, but it's basically talking about how this water heater has to be vented. First thing is that when you come off the top of it, it is supposed to have a 1 foot straight up rise before you use an elbow. Now I know you guys are thinking sometimes we can't get a 1 foot rise because of tight clearances in a mechanical room, in a closet, or whatever. But it should have a 1 foot rise. So what does that mean is that when you're bidding a job or you're looking at a job and the existing vent that came from the old open combustion water heater, the customer needs to know that this is going to cause a problem down the road if we don't do something about fixing it. And sometimes you may not be able to fix it, and there are some alternatives to actually get it fixed. As soon as you get that 1 foot, putting an elbow on it is allowed, even a 90-degree elbow, which I absolutely hate. I prefer to see a 45, so it continues to rise. As we all know, heat rises, and then if you do use that one elbow, you shouldn't use another one for approximately 5 feet. Okay? Approximately 5 feet. The object is to get it to rise out, and later on in this presentation, I'll show you why, okay, and what it causes. water heater was in was probably built when that old water heater was prevalent. In other words, 10 years ago, or 15 years ago, or 25 years ago, when they put a commercial water heater in the room, they had combustion air for that particular style water heater. But every year, or every 4 or 5 years, the combustion air things changes. This is the rule of thumb. This one is a 270.
Yes.
This is a 270,000 BTU water heater. You must have 1 square inch per 1,000 BTUs. So do the math. That's 2,700 square inches of combustion air.
Repeat that again, please.
1 square inch per 1,000 BTUs. So if you got, this is a 270, you need 270 square inches of combustion air. And that can be 1 opening or 2 combined. If it's 2 combined, they must be of equal size. So in other words, you got a lower vent, an upper vent, they need to match the 270 square inches because of the BTUs. Now, most of the time when you take one of these old water heaters out, it's already 270,000 BTUs, and you're thinking, I got enough combustion air, right? Okay, but back in those days, it wasn't 1 square inch. It was like a ½ inch, or maybe even a ¼ inch. Okay, so you're gonna have to improve that airflow. Okay? Do you have to do it for the water heater to work? No, but like I said earlier, it will cause problems. And the third thing, oh wait a minute, the third thing is the gas flow. The valve is a 3/4 inch inlet. The mistake that's always made is that guys will go out and get a 3/4 inch flexible gas line and put into the gas valve. Why is that a problem? John?
Is that enough gas?
It's not enough gas. 3/4 inches outside diameter is not 3/4 inch inside diameter. You can of course hard pipe it and you will achieve that 3/4 inch inside diameter. But a flex line, most of the time if I get a picture and I see a yellow flex line on one of the commercial water heaters, I already know that the gas flow is a problem. I've seen guys actually put a ½ inch gas line on it. And what will happen when you put that ½ inch gas line on it, you'll fire the water heater up. It might fire and may not, or it may not fire. But if it does fire, you're going to immediately start to smell a gas smell. And the guy calls me, hey, it smells like gas, I don't understand. And he'll send me a picture. The first thing I see is a small gas line. I know that it's starting for gas. The inlet pressure on this it's always, everything that this water heater needs is always in the use and care manual or written right on the water heater. Every water heater, even a residential water heater, tells you what the inlet gas pressure must be. Now, I don't know, some of the guys we talked to yesterday carry manometers and multimeters. You guys carry manometers and multimeters? I do as well, but I never pull it out. Never. And I'll tell you why. Because the water heaters today are self-diagnostic, in particular this one, and we'll get into that in a little bit. But anyway, inlet gas pressure is, manual pressure is 2.5 to 10.5. So the water heater will fire at a minimum of 2.5, right? Is it 2.5 or 4.5? No, 4.7, I'm sorry, 4.7, right? I don't know where I got 2.5. 4.7 to 10.5. That's water column. That's actually what the gas pressure is. If you need to check gas pressure, there's a inlet right here on the gas valve that you could actually pull your manometer out and put your manometer on and test it. But here's the clue. You've got a new job, like you guys are doing some of the pizza kitchens. They're already set up with gas pressure. This is how you know. They've got gas ovens, they got gas burners and stuff inside of it. So more than likely, there is plenty of gas pressure when you're changing out a water heater. The only time I really worry about it is when it's new construction. They just put in the gas meter, you know, and you're trying to figure out what's going on and it's got enough gas. That's when you really want to worry about taking out your manometer. Your multimeter is a totally different story, but most of the time I don't pull that out either. And we'll get to why I don't have to pull it out. All right, so those 3 components, and I like to harp on them because, as I said, these pages come right out of this book, and it talks to them. Now, every 3 or 4 years, somebody goes up to Sacramento, lobbies for a bill, and they change air quality. So this is what will happen. You'll get an inspector on your site, and the inspector will tell you, oh, that's fine. Okay, let me tell you a story. I got a call from a guy that said, I just installed a new Rheem water heater in place of an old water heater, and I'm having problems with it. So I drive out to this apartment building, and when I pull up, I see the old water heater in the parking lot, and it's burnt, completely charred up. So I get to the area where they put the new water heater in, and it was a nicely newly built room, which makes sense because the old water heater was burned up, so pretty much the room burnt up too, right? So I look at it, and when I walk up, it has these gates on it, and it's kind of like an outside area, and the gates are about 2 feet off the ground, and there's 2 feet off the ground. So I immediately know, without even looking in there, it has enough combustion air, right? So when I open the door, the first thing I notice coming out at the top is 2 90-degree elbows. So what it told me was that old water heater, which was an open combustion water heater, flamed out and caused the fire. When it fires and that exhaust backs up into the heater, there's only one way for it to go with an open combustion heater, is out of the bottom. And what happened was the landscaper would come once a week or whatever, and he would blow his blower and he'd blow the leaves into the room. Water heater fired and flamed out, and it was gone. Now, that wouldn't have happened if those 90s were not on the top of the water. Very important element, and later on you will find, well, you won't be able to find out when this doesn't fire, but you can take something like, I always do this, take something really like this, and I put it up here, and turn the water heater on, and it fires, and it blows that off. You've got back pressure from your exhaust, okay? Now, if you cannot achieve that rise out of the exhaust, there are ways to do it. There's what they call draft inducers that you can get to put on the exhaust that actually, when the water heater fires or gets ready to fire, this draft inducer turns on and it starts to suck the exhaust out. So when it fires, you don't get that blowback. Now, why is it prevalent with the closed combustion chamber? Anybody know? There's nowhere for that flame out to go except for inside the chamber. So inside the chamber, there's components in there that if the flames flame out like this, are going to cause problems. So we'll get to that, and I'll show you all that in a minute. Any questions at this point? You guys seem to already know what I'm talking about. Is that right? No? You have a sip of mine. Oh.
John, for the 40-gallon gas water heater, for those 90s, it's the same rule?
40 gallon?
Yeah.
Any water heater that has an exhaust on it, yes. Because they're all closed combustion water heaters, and they are low emission burning water heaters. There are some areas in California that don't require ultra low NOx, but they're still closed chambers, so they still need to breathe. A lot of people will take an old water heater. I kid you not, right now, I'm in the water heater business. I have a 17-year-old 40-gallon water heater in my house right now. I bought the house 3 years ago, and it was there, and my wife asked me all the time, when are you going to change it? I have a new water heater sitting in a box right next to this heater, and I refuse to change it because I got to do all this work to it. Okay, so as long as the other one's working, I'm fine with it, so it can stay there, right? And it's open combustion. It's, you know, she says, well, it's more energy efficient. Well, we'll get to that. I don't believe that either, but that's a whole other story. All right. Anyway, so this water heater is self-diagnostic. So when somebody calls me and they tell me they have a problem, first thing I'm going to ask them is, there's a light sentinel on this box. Where are the lights on this water heater? And from what they tell me, or if they send me a picture, I already know what's wrong with it. This water heater is 110 plug. You guys can see that I just put a pigtail on it. So it's, all you have to do really is put a pigtail on it and plug it in, and you're gone. You can hardwire it and do whatever you want to do to get the power to it. But once the 110 is in and the power turns on, there's only one component inside of it that actually takes the 110. After it gets into that, it goes out to 24 volts, which is a transformer. That's a transformer. Once the power goes into it, you can see the wires coming off of it. That transformer converts that 110 down to 24 volts. And here's the interesting thing, is that unlike the other manufacturers, Rheem has color coordinated their wires. So you know where the 24 volts is. The 24 volts is on the blue wire. No matter what, on every component on this water heater, the 24 volts is on the blue wire, so there's a blue wire. On the other brands, you might have to check 24 volts on a red wire or a black wire or whatever, but Rheem has got that 24 volts on one wire throughout the whole system. It's a complete loop, but the blue wire is the wire that you have to test for 24 volts to find out. But again, remember I said that I don't use my multi-tester that much? The reason I don't is because the blue wire has the 24 volts. So if I need to know where it's at, the lights are going to tell me. If you look, first light says power, second light says thermostat, third light says ignition, which is your pilot. Well, not ignition is actually the module. And then the next light is your pilot. The next light is your ECO, which is your safety device, which happens to be the pressure switch, which is this device down here. And then the last one is the main valve. And if you look at the main valve, what do you see down there? So here's the key to this. If you're all the way down at the main valve, and that's the only light that doesn't come on, you know that 24 volts has either stopped there or there's one other possibility that's wrong. So in other words, all the rest of the components are working except for the gas valve hasn't turned on, okay? Because the 24 volts. So if you need to test anywhere, that's where you would test. But as you look on this light signal, any light that's not on, that's where you'll test for the 24 volts. So what you do is, in this instance, here's the thermostat. Take your multi-tester prong, put it on there, and just touch it on the water heater anywhere, and it's going to read 24 volts. Okay? Why? Because your 110 has converted into that transformer, but everything else is grounded, and it's a complete loop for the rest of the wires. So the red, the yellow, the green, all the other wires are actually in a 24 volt loop with the blue wire. Okay? So what I'm going to do, we're going to start by turning this thing on, and the first thing you're going to see is a red light. Okay? I mean a green light. When I turn on that green light, what should happen next? Where should that 24 volts go? To the thermostat. Thermostat is in the off position. Turn it on. We got a green light. Why isn't it on? Didn't call for heat. Exactly. I take that back. Okay. So we're going to turn it on. First thing is going to come on is thermostat light. So where do 24 volts go now?
Damper.
Goes to the damper. Exactly. So before we get into it, I'm going to turn this back off. So we now know that that 24 volts is at the damper because the damper started rotating around, right? The damper has a wiring harness going into it, and it has your blue wire, it has a red wire, yellow wire, and a gray wire, okay? Again, the 24 volts is on the blue wire. If your damper is not working, you can actually jump from the red wire to the blue wire, which gives you jumping ability and eliminates the damper, okay? But if you do that before this water heater fires, you must rotate the damper around and open it. Because if you don't, and it fires, the damper's closed, you know what's going to happen next, right? You're going to be in there choking on the smoke and those emissions, so you have to do that. But when the damper is plugged in, it has a feature on it that, I don't know if the other manufacturers are doing it, but it has a button on the opposite side. Tell me what it says where that button is.
Hold open.
It says hold open damper or automatic operation. The automatic operation is that the damper will open and close on its own. The hold open is that you can put it into bypass mode just by switching that button. And what it will do, it will rotate around and open up, and it will never open or close again as long as it's in that position, okay? Which is a great feature because when you want to troubleshoot a water heater, the first thing I do when I walk up to it is I hit the hold open button because I'm taking the damper out. This damper, or this type of damper, has been on commercial water heaters for about, I don't know, 15, 20 years or even more. And the damper was always a problem. Now, Rheem, as I was talking about with the blue wire, it runs that 24 volts through their whole system through that blue wire, but the other manufacturers don't, just so you know. So if you run into another heater that has a damper, don't think it's the red and blue wire on their heater, because it's not, okay? And if you should happen to jump it, you can make sure that you are jumping the blue and the red wire. If you touch the yellow wire with the blue wire, you got a problem. Why? Look at the wires on the thermostat. Now you have eliminated the thermostat. You don't want to do that. I told the story yesterday. Got a call, guys telling me, man, the water heater won't shut off and the thermostat light is off. It's like, what? I've never heard of this. So I said, okay, so I'll come and see. Excuse me a second. Been talking so much, I'm having saliva in my mouth. Okay, anyway, I get to this job site, and sure enough, the water heater is burning. It's been burning for days. The TMP is popping off. It's just gone, and there's no thermostat light on. In all the years that I've done this with these heaters, I've never seen a thermostat being bypassed. So as I'm working on us, just in case I brought a new thermostat with me, that's the other thing. I've never changed one of these thermostats either. They're just like bulletproof. So I go through the process, I change the whole thermostat, I turn the water heater back on, and the thermostat light is still not on. What happened was, this damper comes in a box, separate from the water heater. I think whoever took this out knows that. Wires would be sitting like this. Guy was doing his plumbing work above the water heater. He was doing his soldering his joints, and I looked and there was solder all running down the side of the water heater. And I looked a little closer and I seen a bud of solder that had went down in the wires and grounded it together. Okay? So if you ever see that the thermostat light is on, more than likely you got something wrong with it here, or there's something touching in here that shouldn't be touching. Okay? The interesting thing is, once that happened, the thermostat was bad. There was no way I had to replace it anyway. I didn't know that at the time. I found that out after talking to one of the engineers back at the factory. So the thermostat still was going to need to be changed. The thermostat itself, there's a little brass screw, and I didn't talk about this yesterday. There's a little brass screw that holds the two yellow wires on right here. Do not take this screw out and think. Do not take this screw out and put, if you kind of look at this right now, what is it, my glass? When I seen this water heater, you can kind of look and see that the wires are kind of off right now in the thermostat. So they should be pushed together. There we go. And this screw that is on here, it's a gold colored screw. And it's not like that. It's flat at the end of it, so it does not penetrate inside the thermostat. What it does is separates the thermostat wires. So I guess one day a guy was messing around with the water heater and he messed around and lost that screw, and he just took one of these one of these self-tapping screws, and he drove it into the thermostat. It disables it too. That screw is really important. If you have to replace it, you need to get a screw that's very similar, not something with a long point on it. Something we didn't talk about yesterday, so you might want to pass that on, okay? Anyway, so the thermostat, the damper, you can bypass the damper by two ways. Actually bypassing it with a paper clip or whatever you need to jump it, or you can just put it into bypass mode. I think I did already, didn't I? Yeah, exactly. No, it's not. I'm gonna flip it back around. We're gonna turn on the thermostat again. And the damper should rotate around. It's now going to the hold open position, and I'm gonna show you what happens when it's in the hold open position. As soon as the damper opens up, you're gonna see the next ignition light come on, but I'm gonna shut it back off for a second. There you go. All right, I'm gonna shut it back off. Now when I turn it back on, the damper won't need to rotate. It'll just go right to ignition. Okay? Very important level. So now we're past the damper. All right. Okay, the other thing you should know is that when you get past the thermostat, the first thing that's gonna happen is the blower motor is gonna turn on. Now, the blower motor, going back to what we were talking about the combustion air, this is how it's fed the combustion air. Okay? This screen right here is a lint debris screen that keeps stuff out of the blower motor. But this is how the combustion air is fed into this unit, and it goes down to the air plenum. In a minute, I'm going to open up the air plenum and we're going to show you. But this screen is relevant. Francisco, come here a second. I want you to read that sticker right there. Read it out loud.
Blower screen may require periodic cleaning, perform cleaning as needed. See maintenance section D of use and care manual or supplement sheet for instructions.
Okay, I think that label should be big, bright, and red, because almost daily I get a call. It's been working for a while, and all of a sudden it shut down, and I don't know why, and I'll ask them the first question, where's the lights on the light signal? Watch this. I usually do this with toilet paper, but I'm going to do it with my hand.
Here it is.
Ah, you got it. I'm going to use some toilet paper and watch what happens. Okay? These things go into a washroom. There's a dryer, there's lint, and lint builds up on that screen. It's going to shut this water heater down. But don't just stop with this screen. As you can see, there's also an inner screen. That inner screen should also be clean. Pull it off, it's going to go right back to the ignition. Okay? Very, very important. But remember, that is not a warranty call. That's a maintenance call. So when you install this water heater, I would talk to whoever runs the maintenance in the PDK or whatever and tell them, we can come back out once every 6 months, charge you $150, and we'll clean it and maintain it. Or you can do it yourself, okay? And since it's an upsell for you. So honestly, nobody ever does it. They call me and they're upset. The problem with this is that when you're cutting off the combustion air, what happens is, if you really listen, you can hear the pilot. I'm going to take the pilot out a little bit so you can see it. The pilot is still trying to light itself because it's at the ignition mode. So what happens when that pilot is constantly trying to light itself? Look what it's plugged into. Plugged into the module. Eventually, this wire is going to heat up and it's going to cause problems with this module, more than likely disable it. Okay? So it could be hours, could be days, and that water heater is just sitting there in this mode trying to light itself, and eventually it's going to burn that module out and you're going to have to change it. But how are you going to know? Because remember, it goes from you know that when it goes from power to thermostat to ignition, that ignition is at the module. So if that light is on right there and it hasn't went past, more than likely that module is burned out. So we were asked yesterday what parts are prevalent. That's part number 1. Okay, well it's actually part number 2, but we'll get back to that in a minute. But it's one of the parts that you should actually carry. Okay? The other parts we'll get to as we go. So once it gets past the ignition part of the sequence, the next thing is pilot valve and the ECO. Pilot valve lights up, you now have a pilot, and now it's checking the ECO, which is what? I said it earlier. No, would be the pressure switch, which is the ECO valve, right? Did you say that?
Yeah.
Okay, well, let me hear it a little bit. If you notice, there's a tube. See what happened when I pulled that tube off? Put it back on, and it fires up. So if this is blocked, what's happening? There's not enough air to actually activate that pressure switch. So there's part number 2 or part number 3 in this equation that needs to be on your truck. Now that switch can be bypassed to get you out of a pinch, to get PBK or whoever you guys are dealing with hot water for the night and you don't have the switch. You can actually pull all 3 wires off, and it's a very little trick. All of my service providers, they carry a little makeshift bypass. It's a paper clip that's bit in an M shape. 3 points, put all 3 wires on it, which you call turn the water heater on, and it will fire. But remember, the ECO is actually a safety device. Is it non-safe? No. But should you get back and replace that switch? I would say yes. Okay? But to get you out of a pinch, you can. Even the guys at the factory will tell you how to do that. Okay? Now the other brands of water heaters don't allow that feature. They don't allow you to actually be able to bypass it. And the reason why this water heater is able to do it is because of that 24-volt loop. What you're doing basically is looping the 24 volts at the pressure switch. Okay? So that little switch sometimes can be the difference between your customer being very pissed off and hot water. So be aware that you can do it, but I know that we were going to get some of those parts in. The problem is that they're different switches for different BTU of water heaters. Okay, so if you got a 200,000, it's not going to work on the 270, and the 270 is not going to work on the 400, and so forth. Okay, because that pressure is different in each one of the blower motors, in particular the 400,000 BTU. Because in 400,000 BTU, this hose is not on the blower motor, it's actually down here on the air plenum because it needs more air. And we'll show you that in a minute. All right? The blower motor itself, somebody asked me yesterday how often do we change that? I said I've only changed one in the last 2 years, and it was because it was too loud. It had like a bad blade or something on it, and it was actually on the 400,000 BTU heater. 400,000 BTU heater blower is bigger, and it has a condenser on it that pretty much gives it that extra, what's the word I'm looking for? CPMs. Is it CPMs? CFMs, there you go. But pretty much the blowers on the rest of the units are exactly the same. So though they are kind of interchangeable, so the 400,000 is the one that does not, that has a completely different blower. All right?
That one's still 24 volts as well?
Yes. Again, once it goes into that transformer, everything is 24 volts. Even though you'll look at this thing right here and it tells you that it's 110, but if you look, what do you see on there? The blue wire. Okay? It has a couple of other color wires on it, but the blue wire is 24 volts. Okay? So if you want to find out if the blower's not coming on, you'll test at this blue wire. You can't do it with the blower disconnected. If you look, the blue wire is plugging into, I believe, into the black wire on the prong, so you would test there. Okay? No, it's actually going to the white wire, I think. It is. The blue wire actually goes to the white wire coming off. Why they did that, I don't know. But 9 times out of 10, the only thing that can stop this blower motor from working is the blue wire on the pressure switch. Take it off, and you get no blower. Take that wire right now, just put it right on there, and you can't see. Blower motor fires up. So again, I took the blue wire out of the equation, and something wasn't working, right? So you guys, the blue wire is going to be your friend with this water heater, trust me, okay? All right, so lastly, is, not lastly, but, the air plenum, the reason why they put this box on here instead of those trays that you used to have to pull out for the combustion water heaters is because it's convenient to service the water heater from the one part that matters most, that is the pilot assembly, okay? So that's the one part that you should always carry on your truck, although if it's installed properly, got the right combustion air, the right exhaust air, and the right gas line, pilot assembly should last the duration of this water heater and then some. It's very rigid. You can actually take it out and clean it up. If it's all carboned up or sooted up, somebody asked me that yesterday, one of those three things is wrong. The combustion air, the exhaust air, or the gas flow, okay? If those three things are correct, you should be able to pull out a clean pilot assembly. 9 screws on the air plenum, you just take them off. I already pre-took off 7 of them.